Today's warm-up question says, if the object shown in the graph starts at the reference point, draw the xt graph for this same motion. So looking at the warm-up, you are given a velocity time graph and you're trying to show what the matching position time graph would look like. And again, this is what you're going to be doing in the activity today as you try to figure out which graphs show the same motion. So we need to be able to go through the same thought process, although in today's activity you won't be drawing them, they'll be there already, but you do still need to know how to interpret each piece of it and what that should look like. So let's go ahead and go over this VT graph and what we know about this object. So I know that this object in my VT graph begins its motion at -3 meters per second. That's not a position. That's how fast it's going. I do want to point out something to all of you. You cannot see position, initial position in a VT graph. I have no clue where this object started if I'm just looking at the graph. But if I read the question, it tells me. It says if the object starts at the reference point. Okay, if that wasn't there, I would have no way of drawing this specific graph because I wouldn't know where to start my position. So just a heads up, when you're looking at a VT graph, you cannot see starting position. But you can see displacement. How far did you move from that starting position? So if you look at this, if you go -3 meters per second and you do it for 2 seconds, because that's what this shows, then how far are you going to go? Yeah, 6 meters in the negative direction, right? So if you go -3 meters per second for 2 seconds, you will have moved 6 meters behind where you started. So we're going to graph that on an xt graph. So this is my xt graph. I really should have labeled it. This is x, this is t. So these are my positions. I'm going to start at the reference point because the question told me to. And after 2 seconds, I need to be at -6. And so the first part of my xt graph will look like this. I'm going to go backwards 6 meters over the course of 2 seconds. Okay, and then after those first 2 seconds, from 2 seconds to 4 seconds, so the next 2 seconds, I'm going forward at +3 meters per second. So if I go +3 meters per second for 2 seconds, I'm still going to go 6 meters. It's just now I'm going forward, which means I will be back where I started. So if I plot that, I'll be back here. 6 meters forward brings me back to 0. Okay, so at 4 seconds, I'm back where I started. Then from 4 to 6, I'm going to go 1 meter per second. So if I go 1 meter per second for 2 seconds, how far am I going to go? It's not a trick question. 2 meters. Guys, remember, all of these displacements that y'all are giving me correspond to the area under my graph, or between my graph and the x-axis. The area of this rectangle right here, length times width, is -3 times 2. That's -6. The area of this rectangle was also 6, but it was positive. There's my +6. And this area across the bottom from 4 to 6 is 2 times 1. Length times width, 2 times 1 is 2. So I need to go 2 meters forward. Okay, again, if I go 1 meter per second for 2 seconds, that's exactly what you'd expect. So I need to be at 2 meters because I was at 0 at 4. So 2 meters forward brings me here at 6 seconds. Okay, and then from 6 seconds to 8 seconds, my velocity is 0, which means I'm not moving. And if I'm not moving, then my position can't change because I'm not going anywhere. So my position, which was 2 meters, is going to stay 2 meters because I'm not moving. Okay, and so this is what the matching xt graph looks like. Okay, notice the shape is not at all the same. But it's not about the shape of it. It is about how you interpret each piece. Okay, so again, you need to remember some general rules for reading these graphs. When you're looking at a velocity time graph, and you already have this in your notes, but some of you need a reminder. When you are looking at a velocity time graph, forward motion will be above the x-axis in the positive region of the graph. Okay, so all of this up here represents forward motion. On a VT graph, backward motion will be in the negative region of the graph below the x-axis. And of course, no motion, if you're stationary, will be on 0. That's for a VT graph. For an XT graph, like this one that we just sketched, how do I know if I'm going forward? What do we have to look at? Slope. Okay, so that means if I look at this graph, negative slope right here means, hey, backward, then forward slower, then no slope, so stop. Okay, again, the slope of your position time graph tells you not just which way, positive or negative slope does tell you that though, which way, but also how fast. You can calculate the slope and it'll give you the velocity. Again, look at my slope for the first 2 seconds. From 0 to 2 seconds, my slope, I go -6 meters in 2 seconds, my slope is -3. Well, guess what? That's exactly what this says. That's why we drew it like that. They match each other. Okay, so you can use the XT graph and the slopes on it to figure out your velocities, or you can use your velocities to figure out what this looks like. Okay, and that's what you're going to be doing in today's activity. But before we get to that, I do want to read you this other thing down here under homework. It says quiz on Monday. Next week, you have a test on Wednesday. And so we're going to give you a quiz on Monday, which is basically going to be like a preview, a practice test. But it's going to be a grade. It's a quiz, but it's a daily grade. Okay, so obviously you have this test and this quiz upcoming. So I wanted to talk about some things that you could be doing to help prepare for your first unit test and for your first quiz over your weekend. So if you're wondering what you can look at, okay, first things first, you guys already took one quiz. You took 104 Mixed Practice CFU in class already. That grade's already in Home Access Center if you haven't checked yet. However, you couldn't tell what you missed and what you got right when you took it, of course, unless you got 100, okay? Then you would know. But otherwise, you don't know. And so I wanted to point out to you that this particular quiz, which again, you guys typed your ID in here, it gives you your link. If you go back to this link, you should be able to see your results now. Okay, so if you were wondering what you missed and what you got right, go back, open up 104 Mixed Practice CFU and check it out, and you can go and look. And of course, you can see your grade in Home Access Center as well. Now, if that grade wasn't great, maybe you got a 57, you might want to do a redo. And you'll notice there is another link right here, redo link. Okay, and so if you didn't do so well, there is a link here that you can use that takes you to a different version of the quiz. And you can go in and you can answer a different set of questions and you can get up to a 70. So if you failed, that's going to be helpful. Now if you passed, you got an 87, awesome. You can still use this for practice. I'm not going to make your grade lower, okay? So you can still go in and use it for practice. But before you do, before anybody does this, I would still recommend that you look at your original one first. See what you missed so you don't make the same mistakes the second time. Okay, so again, that is available to you if you want to go back and you want to look at your score and what you missed, what you got right, and then even if you want to do a redo or if you want to take it for practice. Okay, in fact, all of your past Google Forms, we're going to open them up so that you can use those to study because you weren't able to look at them right afterwards. So we're going to go back in and make sure they're all unlocked so you can go back and click on each one and open it up. I know 104 is unlocked because I did it this morning, but I need to go and check the rest of them, and I'll make sure that you guys have access to those if you want to use them as a resource to study over the weekend or as you prepare for your quiz and your test. Okay, so that is the first thing I wanted to point out. Another resource that is available to you in order to help you prepare for your test is also found in Schoology, and it is up here, Unit 1 Summary for CFU Redo. The Unit 1 Summary is a big Google sheet with a bunch of tabs on it with a bunch of practice problems, and that's all it is. And if you complete all of those practice problems, or at least get up to a 70 on it, I'll also use it for a daily grade redo for you. So if you need a redo and it wasn't on 104 specifically, maybe you didn't do it on 102, then you can do this and use the unit summary. But even if you don't need a redo, it's still a good review. So I would open it up, I would work through it, and use that to help you study as well. So you've got a lot of resources between the things we've already done in class, plus this unit summary, plus this other extra version redo link. Okay, so that's first thing. So, but let's go ahead and talk about today's assignment. 107 card sort is also in Schoology. So if you're not already there, go ahead and make your way there and open up the assignment 107 card sort and quiz. This is your classwork today, but it is also homework if you don't finish it. You should have enough time to finish it, but honestly it depends on how comfortable you are with the graphs as to how quickly you're able to work through it. It's a card sort on Desmos. Now what you open up is going to be a Google Sheet, and I'll show you that in a second. But that Google Sheet has a link to Desmos, and when you go to Desmos, you're going to be matching up graphs, position time graphs, velocity time graphs, and motion maps. And so you're going to be forming sets of 3 graphs, or motion map, that all show the same motion. Okay, and so that is your task. Each grouping will have one of each of those types, and then when you're finished with it, you'll be able to check and see in Desmos on my screen, which I'll put up there in a minute, if you got them right or not, and if you didn't, you can go back and fix it before you take the quiz. Okay, because there is a card sort quiz with this as well. So let me show you what this looks like. So again, when you open up the assignment, you're going to have a spot to type in your student ID up here at the top. Okay, so you need to type in yours. Okay, and when you type in your ID, it will generate your questions. You'll notice that right now I didn't type my ID in, so it says NA. If you don't see NA, it's because you didn't type your ID in. Okay, so type in your student ID because these questions are randomized based on your ID, so you don't have the same version of this as anybody else in the room. I mean, maybe, but the odds are kind of low. So anyway, this is going to give you one of the graphs. So when I type my ID in, now I have a graph there and I can answer the question. Okay, so please type your ID in and then you'll see all your questions. There are only 8 questions here and they're going to correspond with the card sort that you're doing already. So do the card sort first, check and see if it's right, and then come and do these. And leave the card sort open so you can refer to it. Okay, speaking of the card sort, there is a link to Desmos right here at the very beginning of this assignment. If you click this, it's going to take you to a Desmos card sort that looks like this. Okay, and this card sort kind of looks like a mess at the beginning, so what I'm going to recommend that you do to get started, because there's just cards everywhere, is I'm going to recommend that you start by grouping together all of your position time graphs. So some of these say position and time. Group all the position time graphs together. Group all of the velocity time graphs together, which is not how you're actually going to solve it, but this is just to organize the screen. And group all of the motion maps together. So if I see a VT graph, I'm going to stick it over here. If I see a motion map, I'm going to put it right here just to get my screen organized so I can actually see what's going on. Okay, move that. So this is the first thing I'm going to recommend that you do so that you can actually see what you're doing. And then I'll show you what to do after that. So first things first, get the screen organized so you can actually work, because otherwise it's just a mess. Okay, so now it's easier for me to see everything and I can work. And so what you're going to want to do is pick one of your graphs, and it doesn't really matter which one you start with. I'm just going to grab this one. Okay, and so you can start with your position time graph, your motion map, or your velocity time graph, but I'm going to tell you right now, I don't recommend starting with the velocity time graph. That's the hardest one to match. So I would start with a position time graph or a motion map when you're trying to figure out what matches it. And so my position time graph for this one shows that this object is moving forward the whole time, but it's moving fast and then slower. Okay, and I can figure out specifically how fast it's moving by finding the slope of each of these line segments. But that's what I'm looking for, this type of motion, whenever I go and I look at these VT graphs. So this, for example, doesn't show that. This does not show something moving forward the whole time. If it did, everything would be up here. This one has backwards right there. It also has stopping. Okay, so we don't want that. Forward the whole time is going to look something like this. In fact, this matches that, and I can check the slopes as well, but look, forward, forward, slower. My slope must be 2 and then half, and again, you can double check. This slope is 2, this slope is a half. Okay, but that means they match each other. So I've got the first two, those match, and then we're looking for a motion map. So I want something that moves forward the whole time. So again, like this, not going to be it, because this one moves forward and then backwards, so I don't want that. Okay, so you want something that shows the same motion. I don't see it in those three, so it must be in here somewhere. Okay, but forward and then forward slower. That looks like that might be it. Okay, and so I can grab this. Well, actually, I have to close it first. And I can drag it over here. Okay, and on your screen, you can't tell if you did it right or not. On my screen, I can. Okay, and so I can see, yep, those match. And so I know that I have one of them that's good. And so I'm just going to scoot it over here to the side, and then I'm going to pick my next one, and then I'm going to keep doing that. Okay, so that's the process that I would recommend that you use as you're going through to solve these. What you can do is you can look up at my screen, because I'm going to have this on the Promethean with your names. Right now it's made anonymous, so I'm going to turn that off in a minute. But you can look at it and you can see how you're doing. If you have them all right, you're going to have a check. If you have something wrong, you're going to have an X. If you're in progress and not finished, it's just going to be a dot. Okay, but you can check and see how you're doing. Once you have that check mark, you know you're good, then you can go and you can take the quiz over here, and it's going to ask you about specific ones that you've already matched. In fact, look, that's the one I just did. Okay, and so I can then go in and answer the questions based on the ones that I just matched. Some of these are not in there, like this is not specifically in there, but we just talked about what that object was doing, so you should be able to match it. This needs to be submitted. Okay, the Google Sheet, when you're finished, needs to be submitted in Schoology. There is no way to submit Desmos. You don't have to submit it. It saves it automatically. I can see it. You're good. Okay, so once you get that check mark, you're good for Desmos. Okay, so that's what you're doing in class today. Obviously, if you don't finish it during the class period, you can finish it at home because everything's digital. You can open it back up there, but you won't be able to check your card sort for accuracy. Just a heads up, so I would strongly encourage you to work on it in here. In fact, I would encourage you to work together and help each other as you're trying to do your card sort, and just make sure that you're on the right track, and then you can come up and you can check it on my screen whenever you think you've got it. Okay, so I'm going to let you guys get to work. If you have questions for me, please let me know. Otherwise, you should be working on your own or working with a neighbor, and making sure that you get those cards sorted so that you can submit your quiz.